Hi, my name is Joseph D'Agostino. I'm a math teacher here at Freeport High School. I'm applying to be a Desmos Fellow this summer. I'm making this video just to show you my classroom, some of the things that I use Desmos for, and hopefully you select me. Thank you for this opportunity. I really appreciate it. I hope to see you guys this summer. So let's go right to my classroom and see what it's all about. This is my classroom. I've been here for 19 years. I've taught pretty much every class from Algebra 1, Geometry, Algebra 2, AP Statistics, all the way up to Pre-Calculus. I teach at Suffolk Community College as an adjunct assistant professor. I teach statistics, pre-calculus, algebra 2. Currently I'm teaching statistics in algebra 2. So I do have a lot of knowledge, experience teaching. I'm very technologically sound. I have a big, huge technology background, and I just love Desmos. I use it all the time. I'm very excited, especially in this particular school district. A lot of people cannot afford calculators. We use the TI-84 graphing calculators. Not a lot of students have them. We have class sets. So whenever it's time to graph, I said, listen guys, I know you might not have a calculator at home, but go to Desmos.com. So let me show you some of the things that I've done with my students, and I really want to learn more about it with Desmos, and this is a great opportunity for me to go to San Francisco and see everything and work with people just like me that are excited and that want to learn more about the program. So this is my smartboard. I have a Google Classroom that I set up for every one of my classes, and as you can tell, what we did Thursday and Fridays, we worked with logarithms. So in my Algebra 2 class, we were working with exponential functions, converting to logarithms, logarithms back to exponential functions, and the next step was to start graphing exponential functions and logarithms, see what the relationship are between them. So we did it with the calculator, the regular TI-84 graphing calculator. And then what we did was I said, you know what, let's try Desmos. Let's see what we can do with Desmos. So as you can tell, I include Desmos.com as a link to every one of my postings in Google Classroom. So I click on it, and so once they log into Google Classroom, they'll have that on each one of my postings. So if they don't have a graphing calculator at home and they want to do calculations, if they want to do graphing, they have the option. So now, what I did was, alright, you know what? First thing you do is, alright, what does an exponential graph look like? So type in, say y equals 3 to the x. So you go over here, you type it in, y equals 3 raised to the x power. And there's your nice exponential function, y equals 3 to the x. Now if you want, you can zoom in. They like the zoom in and zoom out feature. Alright, so you can move it. Now, they might say, alright, you know what, this exponential function starts at the x-axis. So, alright, let's examine this a little bit further. So let's go ahead and take a look at the table. So we're going to create a table. Now it turns out, -2 you get 0.1111, repeating. 0 you get 1, 1 you get 3, 2 you get 9. Alright, what about, how come it doesn't look like it's hitting 0 at all? Oh, because we haven't gotten there yet. So let's try negative 50. Wow, look at that number. 1.392956 times 10 to the -24th power. Now, if you round, yes, you can round it. Technically it's 0, but it's a little bit more than 0. So it never gets 0. So therefore, just by looking at this graph, we can figure out our range. Our range is going to be everything greater than 0. So now, let's take a look at another So we're going to put back y equals 3 to the x. And what we're going to do is we're going to take a look at a log function. So we started to introduce logs, and now let's see what the actual graph of a log function looks like. So let's type in y equals. Now I like the fact that you can type in pretty much anything you want, functions and non-functions. But logarithms are functions. So I'm going to go to functions, go to miscellaneous, and then I asked the students recently, what's the difference between log and log base A? Okay, now we did introductions to logarithms, so I knew that at least one person, which pretty much they all knew because we had a pretty good lesson about logarithms, is that when you have logs, just a log button, that's log base 10. It defaults to log base 10. When you see log base A, that means that you can put any number you want. Actually, one student said this, and actually I really like this, I never heard this before. You can customize your log base, she said. I said, that's great, I'm going to use that from now on. You can customize your log base. And that's what this is. And we need that here because our log is not going to be log base 10, it's going to be log base 3 for obvious reasons. So log base 3 of x, hit enter, and now you have the blue graph, which is your exponential, and now you have your black graph, which is a log. So now what we were going to discuss is, all right, you know what? What is the relationship between the exponential function and the new log graph that we entered? So I asked the students that, and they said, looks like there's some sort of reflection. One of the students said. I said, that is amazing. That was amazing. So what type of reflection do you see here? What is it? If you were to draw a line, what line could you draw to try to make it reflect? So they were thinking, and then we've done functions before, and they realized that yes, it looks like we're going to have a y equals x line there. So what we did was we typed in y equals x, and that's our new red graph. And guess what? The exponential function and the log function reflect over the y equals x line. And then another student said, that is unbelievable. That is unbelievable. That actually means that they're inverses, right? And I said, yes, that means that they're inverses, because they've known from prior knowledge that if you have two functions or two graphs reflect over each other on the y equals x line, that means that they're inverses. And then what you can do is you can take a look at the table and see if it's true. Now with inverses, the x and y coordinates, they switch. So say you have, in this situation, let's take a look at this graph, this table. 1, 3, right? We have coordinates 1, 3, and if you look at the log graph, what should the coordinates be? And they knew that it had to be switched, so they knew that the coordinates had to be 3, 1, and we could just verify that using the table. And if you put in 3 here, you get 1. Okay, so that was great. So they kind of knew, they discovered that logs and exponentials are inverses of each other. Alright, this was a recent lesson that I did, and once I got the email about applying for the Desmos Fellowship, and I told my students, I love this, I hope I can go, they're rooting for me. Now, if you sign in, you can create your own Desmos programs, your own Desmos activities with your students. I am so into learning how to do that. I wish I can do more with this program. From now until we go to San Francisco, I will be working with many different activities. And now I've taken professional developments that, from the NCTM. I've been to the NCTM. I presented at the NCTM. I actually went to Kansas City this past November, and I presented on outdoor trigonometry. and some of the activities some of the workshops that they provided for us had to do with Desmos, and it was amazing. Okay, some of the things that we've done. So if I do sign into my account, you will see that I've done some activities, but I am willing to learn more. My students love this program, and I want to create more activities. I really appreciate your time watching my video. Thank you very much, and hope to get that call, that email that I am going to San Francisco. Thanks a lot. Again, my name is Joseph D'Agostino from Freeport High School. I'm a math teacher here, and I'm ready to continue my education with Desmos. Thank you very much, and have a good rest of the day.